Okay, so we start with our given here. We're going to prove that the sum of the three angles of the triangle add up to 180. We've got triangle ABC with PR parallel to AC up there. That's given. And then would you agree that angles 1, 2, and 3, they don't constitute a linear pair, they constitute a linear triple, I guess. But those three would add up to 180. Are you with me? So measure of angle 1 plus measure of angle 2. So that's our second step. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. What's the reason on that? A linear triplet? Yeah. Okay. Yeah, we could describe that probably in that way. That would work. But I might just say that those three angles make a line. I can't say linear pair because it's not a pair, but three angles make a line. Three angles make a line. And then here's what needs to happen. I need to swap out A for angle 1, and I need to swap out C for angle 3. Well, if PR is parallel to AC, this goes back to what we've been learning. What types of angles do we have here and here? They are acute in this picture. They are alternate interior angles. And if two lines are parallel, what's true about the alternate interior angles? They're congruent. So, and it works on the other side as well, here and here. So we can say that all together. And so number 3 is angle A is congruent to angle 1. And angle 3 is congruent to angle C. And I'm going to write it out here just to be very specific, and that is if two lines are parallel, then alternate interior angles are congruent. We'll do ALT for alternate, INT for interior angles are, congruent. This thing is a little touchy today. So it says if two lines are parallel, then alternate interior angles are congruent. Something wrong with what?
On here, it's proved measure of angle A plus measure of angle 3 plus measure of angle C.
Yeah, change that to 2. That should say 2. Good catch. All right, so going back up to our picture here, we're trying to prove that measure of angle A plus measure of angle 2 plus measure of angle C, those are the three interior angles of the triangle, are congruent. So now, we've got A is congruent to 1, and 3 is congruent to C. So by the substitution property, I can say measure of angle 1, measure of angle A, that's going to replace measure of angle 1, plus measure of angle 2, plus measure of angle, in place of 3, I'm going to put C equals 180. That's by substitution. And then because of the fact that those three angles make up the three inside angles of that generic triangle, I could draw the triangle however I want, okay, with that parallel line across the top. And I could do this for any triangle. Okay, so that's the idea. So this is proving that the sum of the interior angles of any triangle add up to 180 degrees. So here we go, another equation that adds up to 180. So we've got, they're either equal, right? These algebraic expressions are either equal to each other, add up to 90, or add up to 180. We just added another one, but for a different reason. Right? So, let's see how this applies. So go down and look on the examples on the bottom. What kind of equation do you think you're going to set up there on the bottom of your notes? Solve for x.
plus 180.
Yep, 42 plus 55 plus x equals 180. So 42 plus 55 plus x equals 180. A lot of students would just add up the two that are given and subtract that off of 180. That's what we're doing algebraically. If you add them up, you get 97 plus x equals 180. Then you subtract 97 from 180, you get x equals 83 degrees. That's it. Uh-oh, what about this one? Okay. Okay, so we got 90 plus 2x plus x has to equal 180. You can kind of shortcut this a little bit when you've got a 90 in here. Really what it amounts to is that you could take off the 90 from each side right off the bat. And so the other two angles, this one and this one, have to be complementary. So 2x plus x has to equal 90. And you can combine those two. So 3x equals 90. I'm sorry, what's that?
Oh, no, I asked you.
Yeah. So x equals 30. So this angle would be 30 degrees right here. This angle would be 60 degrees right here. But if one of those angles is the 90, then you could just say that the other two angles, the other two acute angles, have to add up to 90. That would shorten it up a bit. But the big idea is that any triangle I draw up here, the sum of its three interior angles is 180. There's a bunch of theorems that come out of that. Sometimes they're called corollaries. They're bonus theorems. I mean, mathematicians get super excited about bonus theorems. So you have one theorem, and then out of that one theorem, there's like 5 or 6 other theorems that come out of it. Right? Theorems that makes them super happy. What this one does, it has some other theorems that come out of it. This is one of them. It says the sum of an exterior angle, that's this guy out here. Here's how we get an exterior angle. If I draw a triangle, I can create an exterior angle by extending out the line. Like that's an exterior angle. Or if I extended out this line right here, that's an exterior angle. Or if I extended out this one, that's an exterior angle. It's the angle that makes, it's a linear pair with an inside angle of the triangle. Okay, an exterior angle is an angle that makes a linear pair with an inside angle, but is outside of the triangle. So those are exterior angles. So this exterior angle 2x plus 10, according to the theorem here, is equal to the sum of the measures of the two non-adjacent. Non-adjacent means not right next to interior angles. So it's the ones on the other side. And that comes from the theorem that we just proved. And then solve that for x, and then we can find the measure of the exterior angle. So subtract x. X plus 10 equals 65. Subtract 10 from each side. So x equals 55, but it has to find this angle right here that I'll circle by plugging in 55 for x. 2 times 55 is 110. 110 plus 10 is 120. So 120 degrees is our final answer, the measure of the exterior. That's a theorem that comes out of that previous one. So in that case, we're actually making them, setting them equal. We're setting this exterior angle equal to the sum of the two angles on the other side of the triangle, where that one is. All right. Let's check this next one. We've got some little puzzle problem here to solve. This kind of looks like our picture in the beginning. It does say L is parallelogram. It's not marked on here. Let's go ahead and mark it. There it is. Parallelogram. And they give us just one angle. Just one angle.
You also tell us AB is parallel, or is
Perpendicular. AB is perpendicular to BC. Okay, now that's even more information. So they give us one other angle. So whether it looks like it or not,
it's 2.
AB is perpendicular to BC. So that means angle 2 is 90 degrees. Okay, so we got all kinds of information. We can do this. So if angle 2 is 90 degrees, and this angle down here is 120, this guy is 120 down here. What's the measured angle 1? These are same side interior angles, right? Remember what's true about same side interior angles? If the lines are
That would make 160.
180.
180.
One would be 60.
1 would be 60, yeah? Yeah. So that they add up to 180. And then, do I have enough information here to get angle 3?
Well,
Yeah, what do you think? Yeah, what do you think, Craig?
Well, for justifying 3,
Uh-huh.
120 and the AD line,
Uh-huh.
they're supplementary, so that's the angle right there, 60.
Okay.
And then this triangle equals 180. Use put it equal to each other, the 180.
Yeah. And whatever you get, huh? Do you guys have it already? What's it have to be? 30. Yeah, so it's 30 degrees. So there's several little angle puzzles like this for you guys. And the only thing we're really adding is these two other theorems. The one is that the sum of the inside angles is 180, and the other one is that if you have an exterior angle right here, these two non-adjacent interior angles have to add up to that 120 as well. You might be able to use that on some of these. So just adding two more theorems to the ones you already have to figure out these angle puzzles. Okay? So it's not too bad. It's not kind of proof. I think there is, I'm going to ask you, I think there's one proof in the homework for you to do that's kind of similar to the one you did. But lots of applying this idea. This idea gets used a bunch. You've probably already used it before. Probably seen it before. Okay. Any questions on it?